Assalamualaikum warahmatullahi wabarakatuh to our lecturer Dr. Nur Azam bin Arbin and all of you that watching this video. This is our video presentation for MAT300, which is Ordinary Differential Equation. Today, in chapter 3, our group will be present about Newton's law of cooling and warming. Without further ado, let me introduce our group member. First, we have Muhammad Naim Imran bin Nur Daniel. Second, that is me, Muhammad Ashraf Fitri bin Muhammad Kamal. Third, we have Muhammad Farhan bin Muhammad Amirul. Our course code is CS143 and we all from JCS 1435C. Before we go further, let me present about introduction for Newton's law of cooling. What is Newton's law of cooling? Newton's law of cooling is a differential equation describing how the temperature of an object changes over time when it is in contact with a cooler surrounding environment. This law expressed as the differential equation dt over dt equals to k times t minus t naught, where dt over dt is the rate of change of temperature, T is the temperature of the object, T naught is the surrounding temperature, T minus T naught is a difference between the object's temperature and its surrounding temperature, K is a positive constant. This equation essentially states that the rate of temperature change of the object is proportional to the difference between its current temperature and the surrounding temperature. If the object is much hotter than its surrounding, then the difference between the object temperature and surrounding temperature is large and positive. So, the rate of change of temperature is large and negative, so the object cools quickly. If the object is only slightly hotter than its surrounding, then the difference between the object temperature and surrounding temperature is small and the object cools slowly. This principle is often used to explain common observation. For example, a cup of hot coffee. Why a cup of hot coffee cools more quickly when placed in a refrigerator compared to being left on the counter? The refrigerator provides a cooler environment, enhancing the rate of heat transfer and thus speeding up the cooling process.
I will now be presenting the problem statement. Fakrul is experiencing technical difficulties because his PC is overheating. The temperature of his PC is 55 degrees Celsius. Fakrul's room is 25 degrees Celsius. If the time taken for the PC to decrease its temperature from 55 degrees Celsius to 40 degrees Celsius is 12 minutes, and 15 minutes is required for the PC to cool down, we must determine the temperature of the PC after 15 minutes and the time required for the PC to reach 30 degrees Celsius.
Hi, my name is Muhammad Farhan bin Muhammad Amirul, and now I'm going to present the solution for this type of question. So, we let T be the PC's temperature at any time. We knew that the constant temperature was 25 degrees Celsius, meaning that T at 0 minutes is 25. The differential equation related to the problem is dt over dt equals to k T minus 25, referring to subject T0, which is 55 degrees Celsius, and T12 is 40 degrees Celsius. To have a better understanding, we gather all the information given and place it into a table. And then we solve the differential equation as the following, which is integrate 1 over t minus 25 dt is equals to integrate k dt. So we got ln t minus 25 equals to kt plus c. In order to remove ln, we put an exponent symbol to both sides, which we get t minus 25 equals to e power of kt plus c. We can actually separate the exponent power by using product rule, which we get t minus 25 equals to e power of kt and e power of c. Then we let letter A becomes our subject for e power of c, which at the end we get t minus 25 equals to a e power of kt. Therefore, we get our general solution, which is t equals to 25 plus a e power of kt. Moving on to the next step, we apply all the conditions given to find the values of a and k. As you can see, there is a highlighted color of blue mentioning that t for 0 minutes equals to 55. Previously, we already got our general solution, which is t equals to 25 plus a e power of kt. From here, we can match both equations, solve them, and don't forget to replace the value of 0 from the given conditions into a e power of kt. So, we get our value of a equals to 30. Hence, our completed general solution would be t equals to 25 plus 30 e power of kt. After we got the value of a, we should find the value of k. So, in order to do that, we also have provided with other conditions, mentioning that t for 12 minutes equals to 40. The same procedure is applied like the previous one, but this time we substitute the t with a value of 12 from the condition given. To eliminate the exponent, we place ln on both sides of the equations, which at the end we get our value of k, which is negative 0.05776. Once we get the values of a and k, it is much easier for us now to solve the questions. In color blue, stated that our completed equations of t would be 25 plus 30 e power of negative 0.0578t. So, based on the first question, we have to determine what is the temperature of the PC after 15 minutes. To solve that, we just substitute t equals to 50 into the equation given, and we will get the answer equals to 37.6 degrees Celsius. For second question, we have to find out what is the time that is required for the PC to reach 30 degrees Celsius. To solve this, we found an equation which 25 plus 30 e power of negative 0.0578t equals to 30. Then we solve them like usual, and to eliminate the exponent, we place ln on both sides, which bring the power in front. Therefore, we get the answer for the time, which equals to 30.9 minutes.
The conclusion for this problem is that Farkul's PC cooled down to 37.60 degrees Celsius in 15 minutes, and the PC requires 30.9 minutes to cool down to 30 degrees Celsius. From these results, it can be determined that the closer the object to the surrounding temperature, the smaller the rate of the cooling of the object. We can now also conclude that the Newton's law of cooling and warming can now be applied into our daily lifestyle.
That's all from us. Thank you for watching this video. We hope you guys can get benefit from our video and can use it for further study.